I'd like to introduce my colleague, Jeff Holt. Jeff and I have worked together for a good number of years. Jeff has designed some of the many projects that this man has enjoyed over the past few years. Jeff is going to speak to you about 3 projects: the 7th World Trade Center, Memorial Sloan-Kettering, and the Freedom Tower. So I'll turn it over.
Thank you, Carl. Thank you. It's always a pleasure to take a stroll through history. I hope you enjoyed it as much as I did. I never get tired of it at all. And with that, let's talk about some contemporary history. I was going to start tonight by talking about the new research building, yet unnamed, therefore the fairly abstract name, the new research building at Memorial Sloan-Kettering on the Upper East Side. This project started about the year 2000 when Memorial Sloan-Kettering asked us to review their research facilities and contemplate how they might grow in the future. MSK, Memorial Sloan-Kettering, their mission, very simply, is to find cures for cancer. Critical to that mission, as awesome as it is a incredibly close relationship between research and between care. This bed-to-bench relationship that is fundamental to the success of MSK and to the success of their entire practice themselves. I mention this because it really was the fundamental starting point for this project, because it demanded that a new research building be adjacent to existing campus. This contiguity, this relationship of research to cure and care was fundamental. Now, there's plenty of good things about that, not the least of which is that all the researchers, doctors, employees are in this tight-knit community and can not only relate to each other, interact with each other, but everything is all in one place. There's very little transportation outside of that community, very, very little need to move materials around beyond blocks. There's also, however, great challenges with that fundamental premise. The biggest being that there wasn't any large plots of land adjacent to the campus. So with that, our starting point was in this constricted site, of which we were asked to develop a laboratory project of about 700,000 square feet. And in doing so, we had to rethink all of the programmatic adjacencies of a laboratory building, which generally are widespread buildings and green sites. And this, we really had to find a way to develop a new typology of a vertical urban laboratory. These diagrams show us a program, very complex programmatically, to mitigate the bulk of this building, which is 23 stories tall. We actually started to layer that program in a north to south orientation. The building takes a north to south orientation in order to minimize its visual impact from the streets, but also to allow daylight to pass from south to north to residential neighborhoods on the north. There is this layering of laboratories facing northwest, office space, communal areas facing southeast. There are core elements that tie all that together. There is a mid-rise portion that starts to knit the project back into the scale of the surrounding buildings. And interestingly enough, and only in New York City, I can say this with quite a good conviction, we've actually incorporated a rectory into the base of this building. The site, a portion of the site, was actually occupied by a rectory for St. Catherine's, a church that's immediately next door. And as part of the construction, we were to rebuild that rectory with direct links into the church. I think this is why Manhattan is a fantastic place to be. Only in Manhattan would you have a research laboratory and rectory in the same space. The development of the plans were really controlled by 2 factors. One was adjacencies, trying to make sure that in this vertical laboratory we forced as much connection between lab workers, people in the office spaces on one floor versus another floor. And so there is this layering of the plan from the left side of the slide to the east side of the slide, which also allowed us to do quite a bit in terms of daylighting. We have lab spaces arrayed again on the facing northwest. They're immediately adjacent to a whole series of alcoves, procedure rooms, linear equipment rooms, service spaces, and then those are immediately layered into this bar of office spaces and conferencing areas. At the lower floor plan here, at the juncture of offices and communal spaces and labs is a vertical spine, horizontal spine that runs through the entire building. This spine collects, aggregates all of the mechanical requirements, as well as all the vertical circulation requirements. Certainly the greatest challenge of a vertical laboratory is encouraging connections. Or Sloan-Kettering, the culture is one in which buildings really need to sponsor these kinds of casual contacts in which really most of the great thinking happens when two people cross paths, start sharing ideas, and coming up with new concepts. So in order to help those casual contacts, this vertical circulation and horizontal spine that runs through it, we actually started to develop stairs, egress stairs, simple enough. They're on the exterior of the building, glass enclosed, and another assertion I'll make is these are egress stairs that you all want to go check out. Some of the best views in old Manhattan happen in these two locations. That was combined with yet another stair right in the middle, this dense heart of the plan, adjacent to elevator cores and again to conferencing areas, finding ways that we could utilize these connections of people across the floor plate and finding ways to bring light in as many different places as possible as well. The base of the building, again showing how it tries to reinforce the existing street wall and tie the building into its context. Ground floor plan, lobbies extending through the entire site with generous storefronts, skylighting in the heart of this ground floor, since the tower sits to one side, all trying to make this as light and compelling a place to be as possible. Even the conference room, where Dr. Harold Varmus, Nobel laureate who runs MSK, hopes someday to be able to stand and make some incredible announcement of at least a partial cure. That conferencing space is immediately adjacent to the exterior with movable movers so that daylight, whether before, during, or after presentations, could be had. In short, light is really the theme of this project. The laboratories are draped in a curtain wall of glass. An unusual design solution, but one in which technologies of glass have allowed us, I think, to tune this surface in a very specific way to meet the needs and demands of the laboratories themselves. This drawing shows a pattern that we developed. We developed a computer algorithm that allowed us to spread a ceramic frit, a dot matrix across these surfaces in very, very precise and very, very controlled ways. What you see here is bands of glass on the northwestern facade. But between a bench, we have a vision area that is unobstructed with frit, and that frit gains its density as it moves up and away from that vision area. At the bench, the opposite occurs. The frit is densest down near the bench to mitigate glare, and starts to open up as we get higher in the space to try to get light back over and deep into the space. Moire patterns are always a great challenge in the frits. You'll notice many projects are taking this strategy for sun and glare control. We actually found a way within this algorithm to make sure that we could develop other patterns within this dot pattern. Actually, we start to align these dot patterns in a very specific way in which your eye reads the lines around the dots and counterbalances with the rays. Difficult to read other than as a abstract painting here, but we did a ton of sun angle analysis on this building to understand the precise nature of light on each one of these elevations. The result is what I think is pretty compelling. facade, but an even more compelling expression of what's happening inside the facade and how that facade is actually a kind of lens of light for light. It gets more interesting, I think, inside. This natural daylight is combined with dimming controls and dimming ballasts throughout the laboratories. The overhead lighting is actually zoned in 3 zones moving away from the exterior light, so that with daylight dimming controls, our overhead light, which is all indirect, bounced off the ceiling, can be stepped down incrementally in order to maintain a constant level of light at the benches. There's task lighting, which allows us to keep the overhead lighting a bit lower than on some typical labs. But it's this daylight dimming that allows us to garner incredible energy savings. All of this is hooked up to infrared sensors as well to control lighting throughout the building. Occupancy center sensors. Many challenges with occupancy center sensors, making sure that when people are working quietly, the lights don't turn on them. We have manual overrides, we have timers, we have an incredible array of systems here that deal with the very specific lighting requirements of the laboratory. I should mention one little gadget that I think is fascinating as well, is that infrared occupancy sensors have dual contacts. You can actually hook those up to the VAV boxes, the fan boxes in these laboratories. So when no one's there, VAV boxes actually start to come down, their velocities drop, and the building literally goes to sleep. Not only the lights come down, the lights turn off, but even the air circulation in unoccupied spaces comes down. Timers bring it back up in the morning, or if someone walks in, everything can kind of come back and wake up. Small changes like that make a great difference. The southeastern wall, where the administration and conferencing spaces are, has its own daylighting strategies, floor-to-ceiling glass, external fixed sunshades, 3 feet in length, extending off the building at about the 8-foot mark. There are clear stories, glazed office fronts to drive that light as deep into the floor plate as possible. And a whole slew of other analysis, extensive analysis of this exposure that not only let us understand the quantity and quality of shading we get from those external sunshades, but probably even more importantly, we could use an iterative process to actually design specific orientation of those sunshades. Each bar in that sunshade is calculated to maximize light when we need it and to reflect it when we don't. There's a lot of interesting things about this very, very big building. I do want to mention 2 or 3 other components that certainly engineers in the room will get probably pretty excited about. Heat recovery doesn't sound so exciting, but for a building in which it has to exhaust 100% of its air, lab building, 100% of the air that is coming into the building is fresh air, 100% is then expended out of the building. So that tempered air, 70-degree air in the dead of winter is just being thrown away. Typical case in a lab building. Here we have a heat recovery system on top, on the roof, in which that hot air, through a heat exchanger, transfers its heat as best it can to the incoming cold air. So hot air at 70 degrees faces the cold air at 30 degrees. We can preheat the exterior air up to 15 degrees in that scenario, saving, again, enormous amounts of energy. We have in this building probably the biggest incoming steam system, certainly in the last several years here in New York. Steam is used for heating coils, for air handlers, for an array of steam sterilizers throughout the project. And what happens with that steam? When it gives up its heat, it condenses. Usually the condensation is simply thrown away. Even worse, that condensate is so hot, usually use municipal water to cool it and then throw it all away. We're actually capturing all of that condensate, storing it, and then using it for cooling tower makeup. So we won't be dumping any of it back in the municipal system. On a hot, sticky summer day, that'll save 15,000 gallons of water in one day. Combined with that steam system, when that hot condensate has to cool, instead of dousing it with cold municipal water, we actually developed a system in which another heat exchanger extracts that heat, cools it through the exchanger, and then uses that heat for domestic purposes as well. So again, many different small but important details to a building add up to something that I think is compelling in many different ways.